and welcome back to Tutoring Academy tutorials. So today we are continuing our playlist on bonding and chemical interactions, and we will be focused on Lewis structures, all right? So first we're gonna go through very briefly what a Lewis structure is, and then the steps to draw a Lewis structure, and then we are going to go through a few examples to illustrate how you should go about drawing a Lewis structure. Now, what are Lewis structures? It is when the chemical symbol of an element is surrounded by dots. So, for example, carbon. Let me use a different color. If I was to say carbon, right? It represents the distribution of valence electrons. Well, what are valence electrons? Valence electrons are the electrons that are located on the outermost shell. Now, when we look at the periodic table, it already tells us the number of valence electrons for each element in a group. We don't pay attention to the transition elements, okay? So we're gonna look here. So these are all in group 1, so they're all gonna have 1 valence electron. These are all in group 2, so they're gonna have 2. Skip the transition metals, 3, 4, 5, 6, so on and so forth, right? So carbon, it ends up being in group 4. So since it's in group 4, that means that it has 4 valence electrons. So that means there's going to be 4 valence electrons surrounding the carbon atom. Now, when we're discussing the steps to draw Lewis structures, the first thing that you do is you draw out the backbone, aka the arrangement of atoms. So let's just say, for example, we have CH4. All right, this is methane. Now, if we draw out the backbone, we're going to be like, all right, oops. You draw out the backbone, you don't use any double bonds or anything. So we know that we have 4 H's and 1 carbon. Now, the least electronegative atom is in the center. So technically, if I remember correctly, I think carbon has a higher electronegativity, yes, than hydrogen. However, hydrogen is always on the outside. It's one of those anomalies to the rule. Now, we want to count out all the valence electrons for all the atoms. All right, so carbon has 4, but we have 4 hydrogen atoms, right? So each hydrogen atom has 1 valence electron. So 4 times 1 is 4. So altogether we have 8 electrons, right? So now we have to complete all octets for the surrounding atoms. So unfortunately, hydrogen only needs 2 electrons, so it doesn't need the full 8. But carbon needs the full 8. So when we draw it out, we can put it up here. So that's the carbon atoms, right? It has 4, but it still needs 4 more electrons to complete its octet. Well, when we add the 1 electron that each H contributes, we now have 2, 4, 6, 8. So carbon now has the 8 electrons surrounding it in order to have a full octet. Because in order to draw a Lewis structure, every atom, unless it's like hydrogen, needs to have 8 electrons, okay? Now, if we completed the octet of all the surrounding atoms, which is just not an octet, it's just going to be 2 electrons for hydrogen, we would place the extra electrons on central atom. So let's say, for example, we had different atoms here, and we had, like, let's say these were all F's, and we had put all 8 electrons around there. Any additional electrons we will add to the central atom. Now, if the central atom doesn't have a full octet, we would then begin to go from single bonds to double and triple bonds. So just taking more of the electron density from the outside and putting it towards the inside so that we are able to satisfy the full octet, the octet rule for all the different atoms. So, as I said, this is very brief. So now we are going to go over some examples, okay, to make sure you guys fully understand how to draw Lewis structures. All right, so I have 3 examples listed on the board. We will go through more examples this weekend in our weekend review. We didn't have a weekend review last week just because the concepts are pretty straightforward and self-explanatory, but this week we will, to just ensure you guys fully understand Lewis structures. So the first thing that we do is we count the number of valence electrons. So we know that hydrogen has 1 valence electron, right? But we know that we have 2 hydrogen atoms. So that means that there's a total of 2 valence electrons. So then that means that when we draw out the structure, so first you just draw out the structure this way. And then we draw in the valence electrons. Well, we know that this then will be a bond. So pretty much that's saying H is bonded to an H. So this is H2 when we draw the Lewis structure, right? Because each hydrogen is donating one electron. Oops. Each hydrogen is donating one electron. And then when they each donate one electron, those form the single bond. So that is how you do H2. Now let's look here. So H2, we can say for sure we have 2 valence electrons. Oops, let me use it in black. That we have 2 valence electrons from hydrogen, right? Carbon, if you look at the periodic table, it has 4 valence electrons. And that comes from the carbon. And then oxygen, it has 6. Let me triple check though. Yes, it is in group 6. So that is going to be 6 valence electrons for oxygen. So altogether, we get 12 electrons. So when we draw the structure, we have to make sure that there are 12 electrons. So we already said that the least electronegative atom gets the center. Well, hydrogen is always on the outside because it is an anomaly. But between carbon and oxygen, oxygen has the higher electronegativity value. So therefore, when we write our structure, let me make this a little bit better. We will put the C in the middle, the O on the outside, and the H here. Now, we have 2 H's. All right, so now let's go ahead and do the valence electrons for hydrogen. So we know that there's going to be 1 valence electron here and 1 valence electron here. For carbon, I'm going to put carbons in purple. So we're going to do it this way. Boom, carbon, and then we're going to do oxygen in orange. Perfect. All right, so, oopsie. So the valence electrons for carbon, we're going to do that in purple. So that's going to be, well, we can't put anything up there because there's nothing bonded there. So we can put 2 here, 1 there, and 1 there. So far, we have a single bond here, a single bond here. And we already know there's going to be 1 single bond between this atom. But we know that oxygen has 6. So that'll be 1, 2, well actually let's just do it this way. We know it'll be 1, 2, 3, 4, 5, 6, 7, 8. So that's gonna be let's do it this way. I don't want to confuse you guys. So we're gonna do 1, 2, 3, 4, put another 5 and 6, right? So now if we look here, we can see that oxygen has 2, 4. So it has 2 bonds here, 2, 4. So 1, 2, 3, 4, 5, 6. But it needs these 2. So pretty much what we're going to say here is that there's going to be a double bond right there, right? And then it's going to have 2 lone pairs. So instead of putting it here, we're just going to put it here because you can't have that 1 single bond standing alone. You're probably like, okay, so what does this look like? So when we draw it down here, I'm going to draw the complete structure down here. So we have the C, the H, the O, and the H. So pretty much there is a single bond there, right? There's a double bond there, and then there's 1, 2, 3, 4. Now, how do we know that this is right? We should have 12 electrons represented. 2, 4, 6, 8, 10, 12. So that's how you know the structure is drawn correctly, okay? Now when we look here at SiCl4, so Si is a part of group 4. So Si has 4 valence electrons, and then chlorine has 4 times, chlorine is in group 7. So 7. So that's going to be 28. So altogether we have 32 electrons. So we know that Si is going to be the least electronegative element, so that's going to be in the middle. And then we position the other 4 chlorines around it. So there should be a chlorine here, a chlorine here, a chlorine here, and a chlorine here. Now when we get ready to draw it out, well, we know that silicone has 4. So we're going to put silicone in orange, and we're going to put chlorine in purple, okay? So silicone has 4. So that's 1, 2, 3, and 4. Now when we get ready to do each of the chlorine atoms, they each have 7. So let's do purple. So 1, 2, 3, 4, 5, 6, because you know you always want it to have 2, 7. Here, 1, 2, 3, 4, 5, 6, and 7, because there's already 2 on that side. Same thing here. 1, 2, 3, 4, skip that, 5, 6, and 7. Same thing here. 1, 2, 3, 4, skip that because that's already 2, 5, 6, and 7. All right, so pretty much what this looks like down here is Si with 4 Cl's coming off of it. All right, and if you want to make sure that this is correct, so we still have to draw because Lewis dot structure must have the dots. All right, so let's see. 2, 4, 6, 8, or you can just do it this way. 8, 16, 24, 32. 32 electrons because there's 2 here and then there's 6 here. So that's 8, 16, 24, 32, which adds up to the total that's there. So therefore, our Lewis structure is correct. Same as here, it adds up to 12. Same here, it adds up to 2. So that is how you draw the Lewis structures and how you go about doing them. However, if you guys are still struggling with this concept, feel free to book a tutoring session with us at www.tutoringacademy.com. You will receive 20% off your first tutoring session.